Okay, some important points and rules concerning resonance before we finish with this topic. First of all, molecules or ions for which more than one resonance structure can be drawn are especially stable. That's the importance of resonance. It stabilizes structures. The more good structures we have, the more stable the molecule or ion is. So the benzylic carbocation is especially stabilized because we have all of those resonance structures available to it. Secondly, the most important resonance structures are those which contain the greatest number of chemical bonds. You always might want to maximize the number of bonds and the least separation of formal charge. If you can put a bond between two atoms rather than putting a minus on one of them and a plus on the other, you want to do so. Thirdly, this is the most important. When drawing a new resonance structure, you may not move the atoms, just the electrons. I'm going to say that again. You may not move any atoms, not even hydrogen atoms, even though they're small. Even though they're not always drawn in a bond line structure, they cannot be moved. If you're drawing resonance structures, do yourself a favor. Draw in all the hydrogen atoms and make sure you haven't moved any when you're going from one resonance structure to another. And make sure you never draw a structure that would imply having 5 bonds to carbon, because we know that can never happen. Fourthly, the most important resonance structures usually place formal negative charges on the more electronegative elements and positive charges on the less electronegative elements. So for example, the enolate ion, the major or most important resonance structure for it is actually the one with the negative charge on oxygen rather than with the negative charge on carbon. And finally, this may seem like a contradiction of Rule 4, but it's really a manifestation of the fact that the octet rule is the most important rule in chemistry. It is okay to have a positive formal charge on nitrogen or oxygen if every atom obeys the octet rule in that structure. Okay, so this is the major resonance structure for the oxocarbocation, because in the alternative structure we only had 6 electrons around carbon, but in this resonance structure there's 8 electrons around carbon, it's participating in 4 bonds, and there's 8 electrons around oxygen.